Okay, this is part 2 for your response. Chapter 1 test, Form 1A, which everyone had except for a couple people. So let's get started. The first problem deals with body temperature, which we assume is around 98.6, but it apparently actually varies. So here's some data. The 45 males and 45 females, we have parallel dot plots. And we also have some tabular data. They give us the mean for each. I don't know if we'll need. They give us the standard deviation for each, which again, I don't know if we'll need. And they give us the 5-number summary for both sets of data, which is nice because I wasn't excited about entering individual data things into my calculator and getting that myself. So that's kind of cool. All right, so number 11 says to determine if there are any outliers in each distribution. So for this, let's use the 1.5 IQR technique. So to calculate the IQR, remember what you're going to do is subtract Q3 or Q1 from Q3. So let's do the females first. The female IQR is equal to 98.8 minus the 97.9 gives me 0.9. And then I'm going to multiply that times 1.5. And that's going to give me 1.35. So I'm going to subtract that from Q1 to get the low end. Gives me 96.55. And I'm going to add that to Q3 to get the high end. And I get 100.15. So these are the values that I'm using for females. And let's go ahead and check it and see if we have any outliers. On the low end, we're looking at 96.55. And there's 96.5 right there. And so we have an outlier for sure right there. And on the high end, we're looking for anything above 100. This doesn't seem to be 100, or it's right at 100. And then we actually consult the table and we see that it's 100.000. And this other one was 96.4000. I think I put too many O's in there, but this one, the 96.4, is an outlier. Let's do the same thing for the males and check for outliers. So first we're going to find the IQR, and that's going to equal 98.6 minus 97.6 gives us 1.0. And then remember we want to multiply that times 1.5. I guess I can move that over a little bit. That's better. And that gives us a value of 1.5. So then we're going to subtract 1.5 from 97.6. Gives us 96.1. And we're going to add 1.5 to 98.6. And that's going to give us 100.1. So let's clean this up a little bit. There, we can read that. And I'm going to add some equals lines for us. So in the springtime, when you're using this to review for the AP exam, you'll say, oh, we didn't forget the equal lines. Let's check theirs. 96.1. Looks okay. No outliers on the low end. 100.1. Oh, wow, there's nothing over 99.5. So there are no outliers for the males. So you'd want to comment on the one female outlier. at 96.4. 96.4. That's better. Okay, number 12. Draw parallel box plots of these two distributions. Be sure to label the plots and provide a scale. So the dot plots above give us the scale that we want to use, because the box plots and the dot plots shouldn't be different. I mean, they would have the same max and min. And so I can label over here 96. I can label over here 100. And then right in the middle should be 98. And then in the middle between 98 and 100 should be 99. And in the middle of 96 and 98 should be 97. And then I'm going to go ahead and add a half mark in here. If I were you doing it on paper, I would probably scale more than that. But this isn't ideal using this pen. So I'm just going to leave it there and do the best that I can. To do a box plot, go ahead and do the rectangle first. At least that's how I do it. So Q1 for the females at 97.9. So I'm going to guesstimate it about right there. And Q3 is at 98.8. I'm going to guesstimate it there and complete my rectangle. Now the maximum value is at 100, so that's the end of my graph. Over. But remember that the min, 96.4, was an outlier, so I don't want that on my whisker. Instead, what I'm going to do is find the first point that wasn't, which is that guy there. I'm going to guesstimate him at 96.6. Put the end of the whisker there and draw it in. And then go ahead and include the outlier 96.4 on the graph as an open circle. And now I need to complete it with my medium line at 98.4. And this is my female. And I'll go ahead and label it female. For the males, let me go ahead and plot Q1 at 97.6. And Q3 at 98.6. Draw my rectangle. My maximum value was at 99.5. That's not a very good whisker. My minimum is at 96.3, and it's not an outlier, so I can include it. Terrible. Alright, median's at 98. And I'll go ahead and label this as male. So you can see how the parallel box plots and the parallel dot plots resemble each other. And certainly as far as variability goes. That's clear from both of them. Alright, number 13 says to write a few sentences comparing the body temperatures of healthy males and females. So hopefully no one had cold feet on this problem, because you would want to comment on your socks. See where I went with that? Cold feet and socks. Remember, this is spread, outliers, center, and shape. I guess the order doesn't matter, because usually I do shape first. So as far as shape goes, I would say they're both approximately symmetric. For the center, I would say that the female medium is slightly larger than the male. For the outliers, there's a female outlier at 96.4. No male outliers. And if you didn't put this part in there, that's going to be okay, I think, because we should address it in number 11. And so there's no reason to be redundant. And for the spread, I would say the spreads are approximately the same. And so I will say variability is approximately the same. Approximately the same. And to confirm that, look at the IQRs. 0.9 and 1.0. So those are awfully similar. So I think that's sufficient for commenting on those two. Some highlight might be this part. You definitely want to have this in there. And that part. Alright, let's go on to the next page. Alright, data below is the number of unprovoked attacks by alligators on people in Florida each year for a 33-year period. Yikes. We're going to construct a histogram for the distribution. Choose an appropriate bin width and be sure to provide a label and scale for each axis. So when I construct histograms, I like to... Actually, I'm going to pause. Announcement's done, sorry. Hopefully you didn't hear those. I usually like 6 classes. And so if I look at this and I choose 6 classes, the range is from 1... Oh, I don't want a highlighter. The range goes from 24 to 1, which is 24. That's how many data entries are covered, or how many things that possibilities there are. And if I want 6 classes, then I would have a bandwidth of 4. Now I don't want to have a break in my graph, so I'm going to go ahead and put 0 in here. So if my bandwidth is 4, my bin width, sorry, is 4, that means I'm going to have one bin that goes from 0 to, I'm counting on my fingers, but you can't see, 0, 1, 2, 3. So it goes 0 to 3. And then I'll start at 4, and it'll go 4, 5, 6, 7. And then I'm going to carry that on, so forth and so on, to get my different bins. 12, 11, 13, 14. That couldn't be right. 15, and then 16 to 19, and 20 to 23. 1, 2, 3, 4, 5, 6. This is the 6 that I wanted, but because I put that 0 in there, I'm going to have to add another class. So it's 24 to 27. So I wanted 6 originally, but I ended up with 1, 2, 3, 4, 5, 6, 7. Ended up with 7, and that's fine. If you did yours from 1 and then you could get everything in, then that would be fine also. The next thing I'm going to do is get my counts. And so from 0 to 3, I've got 1, 2, 3, 4. From 4 to 7, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Yikes, that's a big one. 8 to 11. I've got 1, 2, 3, 4, 5. 5 of these, and then I just saw that I missed that 6. So we're going to change this to 10 and go to 12 to 15. 1, 2, 3, 4, 5, 6. 16 to 19. 1, 2, 3, 4. 20 to 23. 1, 2, and 1. for my horizontal axis, I'm going from 0 up to 27. So I'm going to choose to put these on here. It's my understanding that if I get 3.1, then it's going to go into this one. Now I know I can't get 3.1, but that's what my graph's going to look like. Hey, there's the phone. Alright, phone ring, so I have no idea what I just said. But I do see what I've done. And so I'm going to make my scale with these being the ends. So 3, that's one class. And then 7 will be the 4 to 7. And then 11 and 15 and 19 and 23 and 27. So hopefully you scaled yours better than mine. Now I need my frequency, and I see the highest value I have is 10. Lowest is 1. So here's 10, which means halfway is 5. So there's 6, 7, 8, 9. Oh, that's bad. 4, 3, 2, 1. So the 0 to 3 class is 4. My 4 to 7 class is 10. 8 to 11 is 5. 12 to 15 is 6. 16 to 19 is 4. 20 to 23 is 2. And 24 to 27 is 1. So this is not my finest, but it'll have to do. Now I want to make sure that I label it clearly. So this is alligator attacks. And on this side, which I don't have room, but you should, is frequency. And that's an okay histogram. Remember, this is for Chapter 1 testing. On your AP, you will not be asked to construct a histogram, because that would be incredibly annoying to grade, which I imagine this one will be too. Alright, so for number 15, it says, based on your histogram, what numerical measures of center and spread would be the best to use for this distribution, and then explain your choice. And this data is not symmetric. Remember that mean and standard deviation go with symmetric, but this is not symmetric. So you would choose the median and the IQR because data is skewed. And mine's skewed to the right, so it's good if you go ahead and put the direction of the skew in there. Don't just say that it's skewed, but explain that it is the direction of the skew. Alright, last page. Oh, yikes, look at the time. It's almost time for lunch. The people's opinion of alt-rock band Coastal Surface depend on their age. Here are some data address this question. So we have a two-way table. Calculate 3 conditional distributions for opinion of the band, 1 for each age group. And then you can present in a table or a graph. So keywords for this one. One for each age group. So I've got an age group, another age group, and then another age group. And I tried to leave the one in the middle as white, so that, there we go. That's not terrible. All right, so that's one for each age group. And so I think for me it's easier just to do tables. I can see why you would like to do a graph as well. do a table and hopefully be able to squeeze everything in there. Alright, so here's my age groups. I've got 11 to 14. Oh, I don't want that. That's better. I've got 11 to 14, 15 to 18, and 19 to 22. And so I'm going to do 18 over 63, 38 over 65, and 40 over 122, 30 over 63, 10 over 65, and 67 over 122, 15 over 63, 17 over 65, and 15 over 122. So that's how I'm going to get the numbers that I'm about to write in. Alright, so you'll be better able to read this. I am going to type them in. Okay, so those are the values, and I've showed you before the fractions where they came from. Just real quick, if you want them again, in this cell it's 18 over 63, 30 over 63, 15 over 63. This cell is 38 over 65, 10 over 65, 17 over 65. This cell is 40 over 122, 67 over 122, and 15 over 122. And number 17 says to discuss the relationship between age and opinion of the band in 2 or 3 sentences. So let's look back at what these are. This is like, dislike, and uncertain. And as far as like goes, that number is much bigger than any of the others. And then, as you would expect, in the dislike, those two numbers are much bigger than that. So clearly there's a preference amongst 15 to 18-year-olds. And 11 to 14 and 19 to 22 show a clear dislike. Okay, so that was the free response portion of your test. Hopefully everybody did really swell. And if you have any questions, please come and see me and we can get it straightened out. It's time to eat.